Hello viewers, Alan here. Thanks for joining me in the workshop again. Continuing with the Lynx, of course, and building on the success from the previous video where I got the camshaft sorted. I was quite pleased with that. I'm finishing out the cylinder head. There were some bits and pieces to do. I needed to put the valve guides in, do some more machining of the ports and fins and such. So there's that. And then I felt like I could start trying to put it all together. So that's the first real assembly effort. So I'm starting to think the finishing line is in sight. So please join me as we make some more progress. Right, so I'm getting ready to press the valve guides into the cylinder head. I'll be Loctiting them in, and to make sure that the process happens under some control, I'm doing it in the press. I mean, I could probably have done it under the drill press or the milling machine, because it shouldn't take that much effort to press them in. It's more about control and being perpendicular and so on. So to help myself, I've made up this little widget. Allow me to push that home, and so that I can manage this little fella. I knocked this up from a bit of scrap. It's intended to, or will, go in there, and there's a hole in the other end which will accommodate the pusher for the valve guide. By design, a fairly close fit. Well, it'll get pushed in the rest of the way when the shove happens. Alright, well here we go, for better or for worse. Now this time I'm going to put the Loctite on very sparingly, as it seems to go everywhere, and it might not even be needed here. So I'm going to put a little bit on the here and see if I can put it around with a screwdriver. Still got more than I need probably. Anyway, let's see how we go. Alright. Well, that seemed to work pretty well, almost too well. My mandrel tried to get stuck in there, which obviously would have been a very bad thing. I'll clean that off thoroughly in a minute before we do the next one. Now let's see if we can clean some of this up. It wasn't too bad this time. Probably can't see it, but there's a wad of tissue there to just make sure no Loctite could get onto the camshaft. That's one done. Let's see if we can get the other one done. Alright, well that seemed to work for the first one, so I'll do the same with the second one, I guess. Looks like that was another success. Be happy with that. Alright. Bit more of a proper clean up, and we'll pull it apart and see how the valves look in there. Well, that looks pretty good. So I want to make a fixture for holding the cylinder head for a bit more machining, and I need some material. So I'm chopping 80mm off this hydraulic cylinder rod, and it's of course chrome on the outside and then induction hardened underneath. So the hacksaw is not interested in cutting through that, so what I do, and you'll see it there, is cut a line around with a friction disc about 4 or 5mm deep, and that allows the bandsaw to get started. So I think you can see it made a pretty clean job of that. It's certainly not a cut I would like to have made by hand with a hacksaw. So So I took that piece of hydraulic cylinder rod that you saw me hack off in the bandsaw to make this fixture. The intention here is to mount the cylinder head on it, so that bolt pattern's been drilled to match that, and that should register in a recess in the bottom of the cylinder head to centralise it. And I've machined it with a 25.4mm shank, so I can mount it in my ER40 collets, and I've got a square collet block and a hexagonal collet block, and I think I'll be using them both for different aspects of the positioning of this thing. And it would also fit in the lathe if I want to do a clean-up or something later on. But this turned out looking really nice. It has a very pleasing appearance. You can see very clearly, of course, the induction hardened layer around the outside, but and you get a beautiful finish when you turn this really hard surface. But yeah, so hopefully it's going to help me get this machining on the cylinder head finished. Right, so I'm getting ready to do the machining two flats, one for the exhaust manifold, one for the inlet manifold, and they're at 90 degrees to each other. The flat for the exhaust manifold should be parallel to the camshaft, and I'm using this protuberance on the top here, which locates the cam box, as a reference surface to make sure I've got that alignment correct. And I think you'll be able to see that it's not a very good dial gauge. The glass is a bit scratched, but anyway, so that's all set up correctly there. And because I've got this whole lot mounted in a square collet block, it's easy to then rotate it to get the correct aspect for machining those two flats. Right, set up now to cut the flat for the inlet manifold. I've touched off. The idea is to machine 13mm wide, that's so from the inside face there to the inside face there, so these two fins get removed, and come down, I think it's 6.3mm from the touch off, which should leave a flat that's 23mm long. So there'll be at least three passes. I'll do one stripe right through the middle to start with, and then edge out to either side. And I think I'll come down from a first pass 2mm deep. Start checking a few things now. This will finish up at 23, or it's supposed to. That's already 25. Huh. That suggests that I've gone deeper than I was supposed to go. But I've only come down 6 instead of 6.3. Well, I don't know what's happened there. But I won't be going any deeper. Let me get a 6mm gauge block. I am 6mm deep, but I'm supposed to be 6.3. I don't know what's going on here yet. Well, I don't know. Well, I'll take it out to the width, the full width it's supposed to be anyway, and then call it done, I suppose. Oh, that looks neat enough, but yeah, I'm a bit of a loss to explain why I didn't get the dimension the drawing shows. Well, if I didn't get anything else right, at least I got the width of the slot right. That's bang on 13. And I'm still mystified as to what happened with the depth of it though. But yeah. Anyway, we'll press on. Hopefully it won't come back to bite me. Right, so now I'm drilling the port through into the valve guide. See how deep I've gone here. I certainly don't want to come out the other side of the valve guide. The issue I've got here is that I need the hole to stop at the centre line of the guide, because the bore of the guide is 8mm and this port bore is 8mm, so I don't want to go past the centre line. So this might be the worst idea I've ever had, but what I'm going to do, I've got this nail sitting in here in the valve guide. The valve guide's got a bore of 3mm, this is 2.8. So I'm going to take the end mill, this is a flat bottom end mill, take it down until it touches the nail, and then I should have to go another 1.6. Alright, well let's see how well that works out. Theory sounds alright, doesn't it? Okay, at least we know where we are now. So I need to come down another 1.4, something like that. Okay, so I think I've got it now. I'll put the nail in and bring this down. I think you can see that's moving the nail. If I leave it there but pull the nail out, it'll go down a bit further. So I reckon that's good enough. If it turns out a little bit of a clean-up's needed, I'll do that by hand when it's out of the milling machine. So time to switch over now to drilling the 4-hole pattern for the mounting bolts for the manifold. Okay, so I've finished machining the inlet port and drilled and tapped for the manifold securing screws. And now I need to return to the question of why the manifold mounting pad didn't turn out to the expected size. I've got away with it on the inlet port because the port was drilled at 90 degrees to the face. But the exhaust port I have to drill at 17.5 degrees to the face, so if the face isn't in the expected position, that angle won't be right. So let's take some measurements and see if we can figure out what's going on. So this, the OD of this thing is supposed to be 57. See, I've got 57.02, so we're on size for the outside diameter. Now I can't directly measure the diameter at the bottom of the grooves because those vernier calipers won't reach in there. But I do have this guy, which is a refugee from my dad's time in the Second World War, I believe. Anyway, I think it still works. So I've got that adjusted, so that's just a nice feel there. And I think it's probably good enough just to measure this with a rule, because hopefully you'll be able to see that we're right on size for 51. So I'm a bit mystified. I'm on size for the OD and also for the minor diameter, but I didn't get the result that I'm supposed to get. So I did my own bit of drawing up in a CAD software just to check that those numbers should have produced that result, and they certainly should, as you can see in this picture. And while editing this video, I've suddenly had a light bulb moment. In looking at that chord picture, I realised that the minor diameter is shown as 50mm, but you might remember when I checked the diameter in the vise, I was happy that it was 51. And here's a picture of the cylinder head, and you can see that it's the upper inner dimension, the upper minor dimension is 51, but lower down it's 50. So I didn't machine the cylinder head correctly. I did all of those fins with a minor diameter of 51, and I'm just pleased that I finally worked out what on earth was going on. Well, I've cut the flat for the exhaust manifold, and no closer to understanding what's going on. I've got a gauge block stuck in there, and I can tell you that that surface there is exactly 6.3 below that, but that flat is 25 wide, not 23. But I decided to focus on the 6.3mm depth because of the need to do an angled port and need to keep the geometry in line with the picture, the drawing. Anyway, that's my hope. So anyway, I'll drill the bolt. While I've got this set up, I'll drill the 4-hole bolt pattern. Okay, so this is my setup for the for machining the exhaust port. The exhaust port has to be done in at 17.5 degrees. So it's a bit tricky, I guess. So when I did the 4 holes for fixing the manifold, I also left a witness mark on the centre, which you might be able to see. I'll zoom in a bit now. Okay, so the witness mark, I think you better just see, is just there. Now, of course, when this lot gets rotated 17.5 degrees, all bets are off and that's lost. So the reason I made this arbor up to mount the cylinder head on was for exactly this, so I could rotate it an arbitrary amount. So that has given me an indication of where the centre line of the end mill should go in, or slot drill actually. Now, to give myself a cross check, I machined up this thing, this stub, which is a very close fit into the tappet hole, so it's concentric with the centre line of the valve. And I used the edge finder to centre on that, and also on the back here, so that I could get the correct offset in that direction, and also check that I was centred this way. And you might be able to see this better than me, but I've got a pointer mounted in the chuck, and thankfully that comes down right on the mark. So I've used two independent methods to locate the centre of the port and the correct angle for the port. So I've got some confidence that I'll be able to push it through, and it might come out centred on the valve guide, which is of course the ideal here. Right, well, we'll see how we go with this 3-flute slot drill. So we've touched off, and according to the drawing this bore should be about 23.3 millimetres deep. Right, we seem to be going alright so far, so I'll press on. I hope I'm not going to run out of height here. About 8 millimetres to go, and that's about, yeah, we're getting pretty darn close. So I reset the cutter to give myself a bit more headroom, or tool room. Let's see how we go. I've got about, I think I've got 4.5 millimetres to go, or thereabouts. So I think you'll be able to see the nail move now. Yep. So I guess we're going to call that done. Right, so I'm setting up a slitting saw in my tool setter. Much easier working with these things the right way up. All those spaces don't fall off. And yes, it looks like I've got plenty of depth of cut, even though it's only a small cutter. We've got to go in 5.5 millimetres. So let's put this in a milling machine and get started. So the beauty of this setup was that now I've finished doing that angled port, I can just reposition this fixture and cut the remaining cooling fin slots. So I finished the machining of these grooves. I can't say I'm very happy with the way it's turned out. There's a few things that haven't worked out so well. I think this cutter was a bit rough for the job, so it's left some raggedness on the ends of the slots. Well, that's on me. But also you can see, I think at the top here, the slot went very close to the side of the hole, and that hasn't come out very well. So I did the top using the dimensions and settings given on the drawing, but for this one down here I actually adjusted them slightly to hopefully get a better result. Anyway, let's pull it out, clean it up properly and see what we can salvage from it. Right, well that's all the TLC this thing's getting for now. Yeah, it didn't turn out too bad, I suppose. So, looking into these valve guides now to see where these ports came out, and if I slip this 8mm dowel in through the port, you'll be able to see that it intersects with the port dead square and on centre. So very happy with that. That was the easy one. That was the inlet port, 90 degrees to the manifold face. The trickier one was the exhaust, which has to go in at 17.5 degrees. But you can see that one was a success as well. Correctly aligned straight into the middle of the port. So very happy with that. That was a little bit tricky getting that sorted. So I was pleased to see I got such a good result. So another day, another mistake. This time I've discovered that the hole pattern to be drilled into the manifold flange is not the same for the inlet and the exhaust. The pad itself is the same size and I didn't pay enough attention, but the hole spacing here is different from the hole spacing here, but I did them both the same. I picked it up because when I pulled the screws out, you can see when I cross drilled it nicked this screw. So what to do? The correct hole pattern is actually quite close to the original, too close to just drill beside it. The new hole might try and run off into the old hole. So what I'm going to do is use these aluminium screws that I've made to fill the existing holes. So I'll put these into their holes with a drop of Loctite. I should be able to machine it off and then drill the correct hole pattern beside the wrong one. That's the plan. Because at this stage I've got a lot of work in this head. I want to save it if I can. Alright, well, let's see how we go. I think what I'm going to do is put a drop of Loctite in the hole first and then put the screw in after it. Now, handling these tiny little screws is going to be the challenge. There's more than a fair chance I'm going to drop one, and recovery options, if I do, aren't good. I need to hold that higher up. Right, let's try that. There we go, that might have it. Now, hopefully that's the first one. I made these about 10 long, so I'm actually surprised that so much is sticking out of the top. So fortunately I woke up to why my screws didn't go in as far as I thought they should. The bolt was still in the hole, so they couldn't get past the bolt. Anyway, I was in time to wind these two in to their full depth. This one went most of the way and I was able to actually just unscrew that one and get it out. That's the one that had the broken top. So I've knocked up another one and we'll see if we can finish this off. Now we know what is going on. There we go. It's a bit better, isn't it? Going straight into full depth. Oh, it's bottomed out. Okay, so we've got a full set done now. That's a bit of a relief. So setting up to machine off those protruding screw ends, I had to put a toolmaker's clamp on the top side of the cylinder head because of course the two bolts aren't there. So that's got all four of them down to within 0.1. So now I've got to do a clean-up pass across the top. Well, it's not a completely invisible repair, but certainly going to be good enough. So now I can drill the hole pattern in the correct place. So that's the holes. All I have to do now is the tapping. Right, I think we've hit the bottom there. So just a quick note in passing, this Sutton tap that I'm using is brilliant, and it cut through this high tensile bolt and threaded it on the way through. So it's a pretty good tap. Right, so it's time to lap the valves. I've done one, do the second one now. Use a small amount of, not that much, use a small amount of paste. Right, so I think that's got some all the way around. We'll just shove him in there. And now we need to be able to twizzle it around a bit. So I'll put this on. To get hold of it. And off we go. The sound has changed now. You probably can't pick it up, but I'm not hearing anywhere near as much of the sort of grinding type noise, and that'll be partly because the surfaces are smoothed out, but also because a lot of the paste has actually been pushed out. So it's time to pull it apart, clean it up and inspect. So cleaning this up is very important. The last thing you want to do is get any valve grinding paste between the valve stem and the valve guide. But that's wiping quite clean now. So there is a small circle that's been lapped. I'll have to have a closer look. I don't think that's in a very good position on the valve face. Well, I think you can see that even though the pattern isn't ideal, because it's right at the top of the valve face, it's a good band, and so I think it'll work just fine. Right, so I've knocked up an assortment of plumbing fittings so I can pressure test these valves. So you've got a pressure gauge there and a bit of a water bath so we can see where it leaks from. Now, I'm not expecting it to hold pressure, just to leak down at a slow rate, but let's see where it actually leaks from. I've got this thing set to do 60 psi, I think. Now I've got to be careful here I don't knock the whole lot over. Okay, so it is leaking out the valve ports, but I think that's a reasonably slow leak down. I think I can live with that. It would have been nice to see a slower leak down rate past the valves, but one thing to keep in mind, I haven't got the correct valve springs installed yet. These are just a couple of like hairpin springs I knocked up to hold the valves against their seats, but they aren't very strong springs. I haven't got the correct E-clips to properly assemble the valve in their valves in their collets at the moment, but I think with stronger springs I'll probably get a slower leak down rate, but even as it is I think it'll work, or I hope so anyway. Right, so this fixture turned out to be incredibly useful. It held the head mounted in the square collet block, the chuck on the dividing head. I had it in the lathe briefly, and somewhere else. Oh, that's right, I also used it for pressure testing leak testing the valves. So it did take more than 5 minutes to make it, but it turned out to be worth every bit of the effort. What I'm doing here is properly fitting this lower cam belt pulley. It has these two screws, securing screws, which I think you'll be able to see, and they stick out, and even when they're done up, they still stick out. They're proud of where the belt runs, so that's no good. So to address that issue, and also to guarantee it doesn't slip, I've machined it took a bit of precision work, but anyway, machined a couple of divots in exactly the right place for those screws to locate in. Now this thing has to fit inside there, and space is at a bit of a premium. So the way I've set this up to make it easiest for myself, first up, I've set the diameter on the crankshaft for this main pulley to be a push fit on here. A push fit on here, and it's a light press fit into the housing, into the back of the housing. So my plan is to assemble this lot. Sorry, my plan is to press the bearing into the back of the housing, and then assemble this lot and push it in from the back. So to make sure, or at least to make it easier to get this thing lined up on that divot pattern, I've made up a little spacer. There's quite a chamfer on one end, and so that little spacer, and so this guy now, so you've got to remember that now what's happening is that the bearing will be in the back. I'll push this thing through, and I have to thread, then I have to thread this pulley onto the shaft and get it lined up with the divots. So I'll be working through that hole. That's why I need to make it as easy for myself as possible. But anyway, with that spacer on the back, those divots are in the correct place fore and aft, and we'll just have to rotate the pulley using the belt until these things line up. So that's the plan. So as you can see, that assembly plan did in fact work out okay, and I've got a mostly complete engine now. So what's left to do? Well, I have to make the exhaust pipe, source the carburetor and make a manifold to mount it, and I have to do something with ignition. I need to find a way of getting a Hall effect sensor and ignition circuit set up. But certainly getting close. I was quite pleased to see that the cam belt pulleys lined up. I haven't got a cam belt tensioner yet, but as it turns out, the the belt tension is probably about right just the way it is without a tensioner. So you've got to be lucky sometimes, I suppose. Also, I have got to. I haven't got the valves properly sorted yet. The camshaft is turning the valves over, but I haven't got the valve clearances set, or there's a whole raft of little bits and pieces like that to sort out, and of course get the valve timing set correctly and whatever. Anyway, I'm quite pleased with progress, so I'm going to call that it for this video. So, thanks for watching, and I hope to see you on the next one.